Thank you very much. So yeah, I'm Panayu, and today I'm going to present my research on supporting real-time in-class student group discussions with AI. In-class discussions play a key role in helping students learn from their peers. This is especially true in courses like ethics, arts, and social sciences, where learning from diverse perspectives is essential. Yet there is a very little support to scaffold this learning process, particularly in large classrooms. So our goal is to empower class instructors to help students help students learn more effectively. So I'm presenting this research today, and there are two parts. One is about using AI to stay on top of dynamic discussion data, and another ongoing work is on using AI for real-time discussion steering at scale. I'll mainly talk about part one today, and since part two is still in the early stage, and we have Q&A at the end. So let's start with part one. To advance this research avenue, we chose to study the way instructors currently support group conversations in an ethics classroom. This is an interesting subject because there's no right or wrong answer to ethical case studies. So peer learning is important. And to better understand the context, let me discuss an ethics class instructor's experience in more detail. So meet Alex, ethics class instructor. Alex has to teach a large virtual ethics classroom. Today's topic is about generative AI and copyright. Alex introduces the topic to the class and set up breakout rooms for students to develop more critical thought and discuss about the topic. And so within each student group, people may have different opinions about this. You hear opposing viewpoints like this is AI stealing other people's work versus inspiration is not stealing and AI is getting inspired by other artists. It is important for a class like this to for students to hear both sides or multiple sides to understand the reasoning behind them. So after group discussion, instructors would do a class-wide debriefing to hear different perspectives and connect back to the learning goals. However, this process is ad hoc, like calling out for volunteers to share what they discussed. So instead of like ad hoc unstructured debriefing, we are proposing like a new approach of a more structured, balanced debriefing with debriefing slides from student contribution in live classroom, and use that as an instructional material. So we thought that we could make it more structured, but in a large class, there will be tons of real-time data, like real-time transcripts, if we attempt to do that. So we specifically study how we can reduce the cognitive load to help instructors focus on the presentation authoring while keeping up with evolving data. So from our series of formative studies, we defined 4 design goals for our proposed system. One is the structured diverse content to foster learning, enable rapid iteration, manage evolving discussions by prioritizing key updates, and maintain traceability between data and slides. So these goals shape the design of the proposed system, which I will introduce Dynamite, real-time debriefing slide authoring system. So as an infrastructure of this system, we have a system. This is the instructor slide authoring interface, and this is connected to real-time student group transcripts in the class. Instructors can use voice and mouse to create the debriefing slide. As you can see, the nodes that populated, those are slides they can use. So that example use voice, or they can use voice plus sketching to create real-time debriefing slides. And they can create visualizations from the sketch. They can also connect to relevant materials like case studies, news articles from, this is a news article from our database, and connect to like lecture slides. So Dynamite provides semantic data binding as a key feature. So this is the first key feature for our project. This feature comes from the need that instructors want to talk about topic most discussed by students or topic the least discussed by students. And but the discussions are still evolving. So Dynamite, we want Dynamite to help maintain the slide content to the most up-to-date information by handing off to AI to help and also like semantically update the slide content with the latest information. So, okay, there are two types of binding that we have. This is content-based binding, represented by solid line. This is the type where instructors want to talk about this topic regardless of the frequency of how much or how the students discussed in the class. Or this is frequency based. This is to help maintain the frequency order. So the user can toggle between each type of binding. And a quick demo of this is when frequency changes, the slide automatically updates the content. It can be adapted to different layouts. And also we can show like pie charts or like this example. And the pie chart should update automatically. Right. So this is the first key feature, semantic data binding. Another key feature is semantic suggestions. This comes from the fact that preparing slides is not a one-time creation because like you cannot just ask ChatGPT to create slide deck and you're done. But in reality, you want to iterate on the presentation. But with such a short amount of time and with evolving dynamic data, instructors need some help with iteration. So semantic suggestions help that by like suggesting relevant like suggestions or to the slide content, so instructors can apply rapidly. So this is a demo of this. So there will be a pop-up on the top of the slide with different content categories. Users can click on the button to show suggested content. If things look good, users can click apply, or they can make edits or refine the suggestion manually and click apply as well. Right, so our evaluation showed that users can produce slides more accurately reflected on the underlying discussion data thanks to the key feature 1 to maintain slide accuracy with semantic data binding. Key feature 2 also helps with rapid refinement as we see more iteration, more refinement per slide. And our research participants reported being satisfied with the final slide deck content. More details, please read our paper. And I'll move on to the next part, which is using AI to help with real-time discussion steering at scale. So semantic updates are good, but there's currently no way to ensure quality of the discussions. Class instructors cannot scale themselves and facilitate every student group. So we are thinking about exploring how AI can help instructors ensure high quality ethical reasoning discussions within the student group. And what that looks like is like covering comprehensive stakeholders or like applying ethical frameworks that are taught in the class. And one insight is logical reasoning or like ethical reasoning on ethical dilemma. Essentially can be represented as a graph that stakeholders, claims, evidence are connected together into a structured network. We are exploring how we can use like sketch-based interaction to help express and guide to meet the target reasoning structure at scale. So a quick demo of this is on the instructor interface. The user can see the current target reasoning structure. When a group starts talking, the component will turn yellow. And when the group finishes talking about that component, it will turn green. Instructors can steer the conversation by sketching on the canvas. And in this case, is to ask like group to discuss opposing viewpoints, and the system can populate the text so that instructors can review and send to the group in real time to steer the conversation to try to meet the quality. So yeah, next step is we want to do some more formative study to understand how instructors balance their expectations with students' contributions, like how much freedom instructors want to let students discuss while maintaining quality. And also iterate on the system, explore how sketching can leverage graph-like structure with logical reasoning or ethical reasoning, and also design how to monitor multiple groups at scale at once. So thank you, and special acknowledgement to Professor Dan Dunlap for his help on this project and sharing his experience teaching ethics. So thank you.